So this is Carrie Cassidy and Bill Ryan, and we're here with Clif from Half Past Human. A very interesting website, I've got to say. So it's great to have you with us, and we are Project Camelot and Project Avalon. So from here, we just want to talk to you basically about your site and about your research and some of the things you're getting in the near future, and then talk about some of those things that you're seeing long range as well.
Okay. You guide. It's entirely your forum here, so you ask, I shall reply.
Okay. To start out with, I guess the most interesting way to start would be to explain a little bit about the technique you've got going on here.
Okay, I'll give you the basic spiel on the thing, and we'll go from there. And in 1994, I came across this idea that I called the language model for storing data while working for some of the high-tech, the largest software companies on the planet. I refined it over time. In 1997, I wrote some software to support the idea in an attempt to mine the internet for emotions around the idea of stocks and bonds, with the idea that if I knew how people felt about them, I could predict what their reaction would be to developing news ahead of their being able to make that actual reaction themselves, with the idea that this could be sold as a profit-making kind of a venture. And in 1997, I came across something that totally flipped my mind about this whole idea, in the sense that I went looking for Stanford University Network, current stock at the time, and came across Sun, because in terms of the solar energy source we've got for it, and noticed that there were some really interesting things going on in the language I was picking up. From there, from 1997 to 2001, I deduced some of the following principles. All people are psychic. Most don't know it. Even if you do know it, it does not impact the next statement I'm going to make, which is that all humans leak out these psychic impressions in the language that they choose to use in ordinary conversation. And that was my basic premise to begin with. My working theory from that point was that if one could sample enough of the conversations going on around the planet and sift for the nuance between why one word might be chosen in an ordinary conversation as opposed to another word for the same conversation that basically you'd had a week ago, then one could determine what is moving us at a, if you will, an unconscious level, and be able to make some forecasts from that in a very interesting way. Sort of an extension, if you will, of my work, of the focus of it in 1997, which was commercial. Make sense?
Yes. Wonderful.
Okay, so basically, at that point, I'm assuming that all these psychics are out there, and I had educated myself on language and how linguistics works and how the human brain works and all this kind of thing. Along the way, I wrote this little piece of software that allowed me to read off the computer screen at up to 2,000 words per minute, so I was able to suck down vast quantities of text over those years. And it led to some interesting breakthroughs on its own. But in any event, the issues about language, it turns out that there is a nuance. We have, taking English speakers as an example, we might know more or less intuitively or internally the definitions of, say, about 100,000 words. Depending on your specialty and what you do for a living, if it's highly technically, that might be slightly larger or slightly less. But any given human English speaker may only use 11 or 12,000 words in any given week. And the 11 or 12,000 words is not static from week to week to week. It shifts. So if we start thinking about this in terms of set theory and fuzzy set theory, which is part of the programming, and I wasn't really into the programming of it all, then we start getting into the idea of, well, why, from week to week to week, do some of the words within our basic set fall out and are replaced by others? And that was my premise, that, oh, well, that's occurring because of something that we are picking up as human antenna walking around vibrating on the planet and also picking up information just because we're here. Again, that sort of makes sense, right?
Right.
Okay, and then...
But what do you mean by that you weren't interested in the... I'm not sure. You weren't interested in the computer modeling side of it, or are you saying someone else took care of that?
No, I did all of that. I was fascinated by the math and the language and so on, and I'm a programmer. That's basically where I came from. I programmed for software companies like Microsoft, I wrote software for phone companies, worked on some very complex stuff, worked for GE, Marconi, and very large companies, this kind of thing. Almost exclusively in the software realm, but eventually it rose up to the point where I was working on algorithms in computer theory as opposed to actual software. Over the course of, I don't know, how many, 15, 20 years or something, it got to the point where the software component of it became less, and I was getting down into the deep sea secrets, if you will.
So, okay, yeah, I would say maybe philosophical side of it began to draw you more.
Correct. And basically, I developed some software that goes on out and eats large chunks of the internet. It reads public domain stuff off of forums and other areas, sometimes strays into chat groups. It's not very deterministic, and it follows links. So sometimes when we set it off, we don't really know where it's going to end up going in terms of what text it's going to eat. And that's part of the whole thrill of it all, if you will. There's a serendipitous approach to this, because we tell the software, which are called spiders, to sit on this server, open up this one web page, go and find any keywords on that web page that we tell you out of this list to start with. And if you find those words, read back a certain number of words and read forward a certain number of words, copy that, do some stuff with it, and if you find any links in there, why, have at it. Go follow those and do the same thing down there. And so it would go and eat the net and move and read more web pages and keep going and going and going. And I think we've got like a 256 limit on how deep it can go in links before it has to unwind and come back and go to the next stage. So it can get some huge amounts of text out of this, on the order of usually about 90 million reads. And a read is a construct that we use where we have 2048 bytes fore and aft, if you will, of the keyword that it's found. It constitutes a read, but it also brings back the context of where it found that. In other words, is it a gardening forum, is it baking, car repair, whatever, and some other information, date, time, and so on.
But in essence, this is something Bill and I had been discussing, asking each other whether or not you actually were feeding it keywords that you were looking for.
That part of the process is extremely unique, and I don't want to go too deep into it because it actually is the real key to the thing, I think, and it's a trade secret. We do have a seed list, and we do have a seed list of 300,000 forums to begin hunting in. But no, it is not deterministic in the sense of data mining, where we say going out and count the number of times you run across the, tire or, wall or bridge or something. It doesn't work that way. It says, basically what we're saying is this. Here's a long column of what we call context. These contexts can be thought of as the name for a larger group of words. And you might give it 30,000 of these names to start with. And one of them might be solar or energy. And we tell it, okay, take the word energy out of this long list of 30,000 words, go over and read the entire context that we've got associated with that, and store that in your memory. And that itself might be 30 or 40,000 words. And then go over to this website and see what you can match out of that in the following manner. Make sense?
Okay, it sounds even more complex than I originally thought. But
what that tells me is that instead what you're doing, actually, you're looking for significant correlations. Is that a better way of looking at it?
Correct. We don't actually even look at the words. The words themselves, and the whole thing is written in the spiders and so forth are in a much more deterministic software language called C in some Perl scripts. Most of the processing is done by Prolog, but the Perl scripts go through and do a match and replace, if you will, and from the time we actually find any of the words we're looking for, from that point on, really it always deals with it as a 4-digit text number that we assign to it. And that's just so we're not dealing with the word itself. But we are indeed, perhaps you heard that the government has this, the U.S. government has this software out there that says, this fellow dialed that fellow on this phone number, or he sent this fellow an email, and it tries to develop up the concept of networks from it, right? Who's talking to who? Not about what, but just who's talking to whom.
Well, we actually heard that, they do use keywords, though.
Oh, sure. But basically what I wanted to come back to is that Bill's correct. What we're actually doing is we're not looking for the words per se, nor the count of them or anything, but the relationships between that word and other words, because we're looking for the nuance.
I can understand how by taking this very data-dense snapshot of the web, you can find out what's happening now and what people are looking at now. But how do you target specific points at a future time and at a specific future time?
Okay, so we send the spiders out, and they go out and they find out that, they get real excited and they come back and they tell us that somebody's using the word jack, like I jacked my old lady's car, okay? Now, we think about that word. Basically, a lot of this was all down to slang anyway to get the idea across. We look at, we've assigned, let me back up. I got a copy of the Oxford English dictionary in the form of a lexicon, just a list of all the words. Way back when, in 1994 or something, about 300,000 English language words. And I started assigning values to these things in a numeric way to assign emotional relationships with them. So that I would say that, this word fear